Hello everyone, welcome back. In this video, we're doing something different. We'll start with differentiation and then use part of that result to help us integrate a function that we wouldn't normally be able to solve directly. This kind of questions test your understanding on how differentiation and integration are connected. Sometimes we're given a tricky looking function to integrate, but by recognizing that it is part of a derivative we've already worked out, we can reverse the process and solve it easily. These questions are typically given when they give you an equation like so and ask you to find the differentiation of it, and then hence find the part of that differentiation, which I will show you later on. In this video, we'll break it down step by step, show you how to spot these patterns and apply it into real exam style questions. All right, so let's get into it. Now, in this first question here, given that y is equals to x squared ln x, find dy dx. Okay, the first thing we're going to do is we're going to differentiate this. So differentiating this using the product rule, first differentiate left, then copy right, plus differentiate right. Differentiating ln, you get 1 over x, then copy left, you get x squared, right? Simplifying for this equation, you get 2x ln x plus x. This is your dy dx. Now, the question will always be structured this way. The next part, they will ask you to hence find this integration. If you look carefully at this integration, like I mentioned earlier, you do not know the working or the formulas for these type of integrations that they've given you. But these functions are actually part of the previous question. Look, this is x ln x. So what we're going to do is we're going to have to isolate this part of the function. Now, looking at the examples that I've given you here, when you have to integrate a fx and a gx, you can actually separate them by integrating fx plus the integration of gx, and then lastly, moving the gx to the right-hand side of the equation. And also similar to this question, if you have a multiple on the outside, you can actually bring the multiple out of the integration and lastly bring that multiple to the right-hand side. Okay, so we'll be applying these two functions here, these two methods, I mean, and then for this question, integrating this, we know that if we were to integrate the front part here, so we'll always start with by rewriting what our previous answer was plus integration of x is actually equals to x squared ln x, right? Then from here, like I mentioned earlier, we're going to bring this out, integrate this, and bring it to the right-hand side. So writing each step, you will get 2 integrate x ln x is plus with this integrated, you will get x squared over 2 is equals to x squared ln x. Like I said, x squared ln x is from the question, right? So when we bring everything over, the integration of x ln x is supposed to equals to x squared ln x. Bring this over is minus x squared over 2. And then bring the 2 over means the whole equation multiplied by half. Finally, simplify this equation here. You get 1 over 2 x squared ln x minus x to the power of 2 over 4 plus c. Okay, very important to include the plus c only at the back instead of adding it here, and then when you divide, you get c over 2. This is the wrong way of doing it. So like I said, only add c at the very last step. Okay, now next question. It is given that y is equals to ln 3x over x squared for x greater than 0. Find the differentiation, give your answers in the form of a plus b ln 3x over x cubed, where a and b are integers. Okay, so nothing's changed. What we're going to do is we're going to differentiate for this. Dy dx is actually equals to differentiating ln 3x. You would have gotten 3 over 3x. Then copy the right, x squared minus differentiate bottom, you have 2x. Copy the top, so ln 3x. Diff over the bottom square, so you have x squared to the power of 2, right? Simplifying this equation here, you would have gotten cut 1, then this is just x minus 2x ln 3x over x to the power of 4. Then from what it seems, we needed to have a denominator of x to the power of 3 only. So we're going to factorize this out. X 1 minus 2 ln 3x over x to the power of 4, which actually just simplifies to 1 minus 2 ln 3x over x cubed. Then we're done with this part of the question here, right? Now, the next part is, hence, find ln 3x over x cubed. In this case here, when it is a fraction, remember that you can actually split the fraction up as long as they share the same denominator. So, starting from here, integrated 1 over x cubed minus the integration of 2 ln 3x over x cubed is actually equals to ln 3x over x squared, right? We're just rewriting back the question from earlier. Now, same like previously, we are actually going to bring this 2 out later. So integrating for this, you would have gotten 1 over x squared, then bring the negative 2 down. Then this will actually be negative 1 over 2x squared. Then minus the 2, bring to the outside, 2 integrated ln 3x over x cubed is equals to ln 3x over x squared, like so. Now, bring everything over together. Bringing this to the right-hand side, you would have ln 3x over x squared plus 1 over 2x squared, right? And then multiplied by a negative 1 over 2. So the integration of ln 3x over x cubed is equals to this. Then from here, expanding the bracket, you get negative ln 3x over 2x squared minus 1 over 4x squared. Then remember to plus c, right? This will be your final answer here. Okay, next question. Differentiate tangent x minus square root of x with respect to x, then hence find, right? So as usual, what we're going to do is we're going to differentiate this. Dy over dx is equals to, differentiating tangent, you get secant square. Then the same thing on the inside, x minus sert x. Then what's going to happen is we're going to bring the differentiation of this function on the left-hand side here. You would have gotten 1 minus 1 over 2. Then it becomes x to the power of negative 1 over 2, like so, right? Rewriting this, you would have gotten 1 minus 1 over 2 sert x secant square x minus sert x, right? Then from here, hence find the integration of 2 sert x minus 1 over sert x cos square, this whole thing here. Now, cos square, we know that is actually secant square is 1 over cos square. So this will actually become this, whereas How do we get the numerator to be 2 cert x minus 1? It's actually by combining this into a single fraction. So this changes to 1 minus 1 over 2 cert x uh, secant square x minus cert x, okay, is actually equals to 2 cert x minus 1 over 2 cert x cos square x minus cert x, right? Now that we have this, once we have this already, we can actually just simply bring out the 1 over 2 at the bottom. So when we integrate this, integrate 2 cert x minus 1 over 2 cert x cos square x minus cert x, like so. This is actually equals to previously tangent x minus cert x, tangent x minus cert x, right? So from here, bring the 1 over 2 out, 1 over 2, 2 cert x minus 1 over 2, sorry, over cert x cos square x minus cert x. And this is what we're looking for from the question, right? Okay, is equals to tangent of x minus cert x. So finally, just bringing the 1 over 2 over, cert x minus 1 over cert x cos square x minus cert x is equals to the 2 of tangent x minus cert x plus c, right? So once again, a reminder to make sure to include your plus c because this is worth 1 mark for some questions.